In this video, I am going to walk through the steps of using an Excel spreadsheet to approximate the value of this given integral. Now, of course, with the fundamental theorem of calculus, we do not need to use midpoint rule to approximate this, but I'm just using it because it's a very simple example, one that we can employ really easily. And I'm not going through any of the steps of figuring out, accuracy or anything like that. I just want to demonstrate how we can use a spreadsheet like Excel to implement the midpoint rule for approximating the value of an integral. So here we are looking at the integral from -2 to 4, x squared plus 3x dx. We are going to use 45 steps. In other words, we're going to let n be 45. So in that case, we have that x sub I would have to be -2 plus 2i minus 1 over 15. If you're not sure where that comes from, please make sure that you can work it out and get that value. Delta x is going to be 6 over 45, which is 2/15. Sorry for the typo. That should be equals. And then using the midpoint rule, the integral would be approximately the Riemann sum of putting these values, squaring it, multiplying by 3, adding it, and then multiplying by our delta x. So this is the recipe. Of course, we now have to go cook this thing. So let's jump over to our Excel spreadsheet. And I'm going to, there's multiple ways of doing it. I'm going to walk through the way I would do it and just breaking up very simply. So first off, I'm going to have one column that is for my index, I. I'm going to have another column for my variable. I'll call it x sub I. And again, you don't have to label this. It just makes it easier when you come back to it to remind yourself, oh yeah, what was all this stuff? Then I'm going to have to evaluate the function of x sub I, and then I'm going to have to multiply it by delta x. Write that, and then we will have the approximation. Now, since dx doesn't change, I'm going to go ahead and just put it right here. Again, this is not necessary, but I'm going to show you how this will work nicely. So I'm going to calculate the dx. Now, to do any calculations in a spreadsheet, you've got to tell it you wanted to calculate. Because if you notice, up here I was just typing stuff, and whatever I typed is what it went there. But if I want a spreadsheet to calculate something, I need to tell it equals. In this case, this will be 4 plus 2 divided by 45, which is 0.13333. Now, over here, my index is going to go 1 to 45. So I need to start at 1, 2, and it would be really annoying if I had to type 3, 4, 5 all the way up to 45. But thankfully, Excel is smart enough. It'll recognize I wrote the first 2 numbers in my sequence, and it'll say, oh, I know how to build this sequence. And I'm going to just drag it down to, in this case, it'll be the 46th row, because that will give me 45. So let me show that again. For anyone who has never used a spreadsheet, this might seem like a little bit of magic. So what did I do? I said, this is the beginning of my sequence. And if you'll notice in Excel, there's a little dot here. I'm not sure how they do in Google Docs. In Numbers, the place you hold on to is actually in the middle. But that won't work great here. So whichever program, you have to learn the little subtleties, but there should be a little place where you just latch onto, and then I start dragging it down, and for as far as I drag it, it'll give me that, it'll grow the sequence out. So let me continue pulling this down, and we are to 45. Now, this is my index, so everything else is going to be built off of that. So let's go back and look at our formula for the x sub i's. The x sub i's, it says -2 plus 2 times I minus 1 divided by 15. So I literally will just take this formula and put it in, though I do have to tell it where the i's are. So this equals -2 plus 2 times And then where's my I? Well, the first one will be right here. So I'll say, click it. And so where I just clicked it, but notice what it filled in was the address of that cell. It is in column A. This is column A, row 2. That's the literal address of that index 1. So 2 times my I value minus 1 divided by 15. It gives me a number. And now what do? I'm going to do the exact same thing. I just have to do it once because I've given it a formula this time. And so I will drag it down and down to 45. And here we go. Now so it just filled it up with numbers, but if I double click, you'll see the formula, -2 plus 2 times A46, column A, row 46. So it filled it incorrectly. It's going to be putting the number 45 in that spot. Whatever is in this cell gets replaced in the computations in that spot. And it continues on, right? If I double click this, we can see it's got the right cell, A44. Okay, so that's our x sub i's. Now how about f of x sub I? So remember our formula, let's go back. Our formula is xi squared plus 3xi. So I've already computed what the values are for the xi's, so then I just have to do this guy, whoops, let me do an equals this value squared plus 3 times this value. And so the answer is -2.26. Doesn't do anything for us, but now I'm going to drag it down, fill it up, and these are the values for each of these. Again, I can click this and I can see this is B46, column B, row 46. This number is being squared, multiplied by 3, and then added together, giving me this value. And finally, I need to multiply each of these values by this number. So equals this number times this number. Now, watch what happens when I draw down now. I'm just going to do a few. Notice it's 0. And we know that's not correct. Why is that 0? Let me double click this and notice, oh, because when I drag down, the original cell I built was pointing here and here. This number times that number. So when I drag down, it thinks that I should do this number times that number. So there's something interesting going on here. I want this to stay static, but slide through these. So how do I do that? Well, in Excel, I'd put a $sign here, and now it will be frozen. Again, I think that's the same syntax for Google Docs. If you're using Macintosh numbers or Apple numbers, there's a drop-down screen that if you click on it, it will tell you to preserve the row. So by putting a $sign there, I'm telling the program there's no $sign here, so slide along with those, but do not slide this one. So if I slide it down, now we get numbers here, and I can see, sure enough, I'm in the right cell for the f of xi, and I'm in the right cell for the dx. Again, you can see it again. This is F2. It doesn't move, but this is C4. I'm in the right place. So let's fill this all up. And finally, let's get the approximation. So we need to add these all together. So how do I do that? Well, Excel has an internal function called sum. Surprise, surprise. And I have sum, and then I will highlight all the numbers I wanted added together. So I start here, and then I just slide down with my mouse, and I get to here, and we can see that what Excel wants to do now is add up all the values running in column D2 all the way through D46, which is exactly what's highlighted here. So hit enter, and we get an answer, 41.9911111, which, if you work this out by hand, the integral is actually 42, so it's an okay approximation. It's accurate to 1 decimal place. But again, this is not what I would use to solve this problem. This is really just an example of how to use a spreadsheet to approximate the value of an integral. Hope that helps, and happy mathing.